Welcome back, class. Today I am going to show you how to factor a binomial with a degree of 4. I'm also going to show you how to factor a trinomial with the greatest common factor. Let's get started. So in this problem, we have 16x to the 4th minus 81. Notice how 16 is a perfect square, and so is 81. And believe it or not, x to the 4th is also a perfect square because x to the 4th is x squared times x squared. Because 16, x to the 4th, and 81 are all perfect squares, let's go ahead and factor this by using a difference of two squares. Remember that the word difference means to subtract, and that's exactly what we're doing. We're subtracting the 16x to the 4th and 81. So let's go ahead and apply the pattern. And if you forgot the pattern, it's a squared minus b squared is equal to a minus b times a plus b. Let's take this pattern and apply it. So go ahead and draw your parentheses. We know that we're multiplying a binomial to another binomial. We also know that these binomials are going to look pretty identical, other than the fact that one's positive and the other one's negative. Now let's fill in the blanks. I know 4 times 4 is 16. And I also know x squared times x squared is x to the 4th. 81 is 9 times 9. Or 9 times negative 9 is negative 81. Now you need to look at each factor to see if it's still factorable. 4x squared plus 9 is no longer factorable. But 4x squared minus 9 is another difference of squares. So I went ahead and wrote DOS, which stands for difference of squares. 4 is a perfect square, and so is 9. So let's go ahead and use the difference of squares pattern to factor that out. Draw the parentheses, put the plus sign, and the minus sign. Now let's fill in the blanks. 2 times 2 is 4. X times x is x squared. And 3 times negative 3 is negative 9. Now that we've factored out 4x squared minus 9, let's go ahead and write our answer. Let's bring down the 4x squared plus 9 from earlier. So we have 4x squared plus 9 times 2x plus 3 times 2x minus 3. These are the factors of 16x to the 4th minus 81. Let's look at part B of this you try. I'll go ahead and rewrite part B. Part B is 16g to the 4th minus 625. So notice how this is also a difference of squares. 16 is a perfect square, and so is 625. So let's go ahead and apply the pattern. We're multiplying two binomials together. We know one binomial is positive and the other binomial is negative. Now let's fill this in. So 4 times 4 is 16. G squared times g squared is g to the 4th. 25 times negative 25 is negative 625. Now let's look at our factors. 4g squared plus 25 can't be factored because you're adding the two perfect squares. However, 4g squared minus 25 can be factored because it's a difference of squares. So let's go ahead and factor 4g squared minus 25. Draw the parentheses, draw the plus sign, and the minus sign. Now let's fill in the blanks. 2 times 2 is 4. G times g is g squared. 5 times negative 5 is negative 25. Now that we've factored 4g squared minus 25 completely, let's go ahead and bring down the 4g squared plus 25 from earlier. So 4g squared plus 25 times 2g plus 5 times 2g minus 5 are the factors of 16g to the 4th minus 625. And this is our answer. Now let's look at something a little different. We want to factor the polynomial completely. This time we have a trinomial with a degree of 8. The first step is to factor out the greatest common factor. So 2, 10, and 12 are all divisible by 2. They also have a common variable, and the common variable is p squared. You want to factor out the smallest variable. Now let's fill in the rest. 2p squared times p to the 6 is 2p to the 8th. Remember the rules of exponents. When you're multiplying two variables with the same bases, you add the exponents. So 2 plus 6 is 8. Let's move on. 2p squared times 5p to the 3rd is 10p to the 5th. And 2p squared times 6 is 12p squared. This should look familiar now because we have a trinomial. And if it's a trinomial with an even degree, we're going to use the x method. A is 1, B is 5, and C is 6. Let's use the x method. At the top we have A and C, and at the bottom we have B. 1 times 6 is 6. 5 is going to go at the bottom. Now we need to think of two numbers that'll multiply to 6 but will add up to 5. And those two numbers are 3 and 2. 3 times 2 is 6, and 3 plus 2 is 5. Now take those numbers and divide by A. A is 1. Now we need to think of two identical variables that'll multiply to p to the 6. Those two identical variables are going to be p to the 3rd times p to the 3rd. P to the 3rd times p to the 3rd is p to the 6th. Now let's write our factors from the bottom up. So we have p to the 3rd plus 5 times p to the 3rd plus 2. And both of these binomials are not factorable. We also factored out a GCF from earlier. We need to take that GCF and bring it down because no one gets left behind. That GCF is 2p squared. So the answer to this problem is 2p squared times p to the 3rd plus 5 times p to the 3rd plus 2. These are the factors of 2p to the 8th plus 10p to the 5th plus 12p squared. So if you like this video, go ahead and give it a thumbs up and don't forget to subscribe.